Hello and welcome back to IXL tutorials. This is Mr. Duffick and today we are on IXL L5, which is reflections. And on these problems, we are going to be dealing with graphing reflections on a coordinate plane. So right here at this problem, we have a graph, nice little graph, okay? And we have a triangle with points B, C, and D, okay? Now, if you remember from class, you remember that when we reflect something, we reflect a shape over what's called the line of reflection, right? So we go up to our problem or our question here, and it says, graph the image of triangle BCD, so triangle BCD, that triangle right there. We're going to graph that after a reflection across the y-axis. That's just saying that we're going to reflect this triangle over the y-axis. Okay, so for that, first we need to identify the line of reflection. So the line of reflection, it says, is the y-axis. So we go on our graph and it's made up of two axes, right? We have the y-axis here and the x-axis here. The y is always vertical, it's always up and down. The x-axis is always horizontal or left to right. Okay? So it's saying we're going to reflect across the y-axis, or the y-axis is going to be our line of reflection. So I'm just going to highlight it real quick so we can kind of see where it is. Okay, so we're going to reflect this triangle over this line of reflection. All right, so there's a couple different ways you can do that. The first way that we will do is we are just going to count, right? You can reflect anything you want on graphs as long as you can count. So we're going to start here, and the key here is every pre-image point, right? Every initial point on our first shape, that is always going to be an equal distance away from the line of reflection as its image point, or as the points on the second shape. So what that means is, for instance, point C right here. Point C is 1, 2, 3 units away from the y-axis. So if we're 3 units away from the y-axis, all we're going to do is count 3 more in the same direction. So 1, 2, 3. And right here is going to be our reflected point C prime. Okay, so we reflected point C over the line of reflection, and now we have C prime over here. So we just reflected 1 point. Now we're going to reflect the other 2 points. So we're going to go to B now. Point B is right here, and we're going to count 1, 2, 3, 4, 5, 6, 7. And then we're just going to go 1, 2, 3, 4, 5, 6, 7. Okay. So this point right here is going to be B prime. Okay. Now let's do the last point, D. D is going to be 1, 2, 3, 4, 5, and then 5 more units. 1, 2, 3, 4, and 5. Right there. Now I'm going to try to draw 3 straight lines. 1, 2, and 3. We just connected the dots. And so it looks like we have reflected our triangle from our quadrant right here over the line of reflection over to this quadrant over here. So we just reflected that triangle, okay? So what that looks like over here is we're going to go 1, 2, 3, 4, 5, 6, 7, okay? I think I'm going to redo this just because it doesn't really need, well, just going to use this one. Okay. Hello, and welcome back to IXL tutorials. This is Mr. Duffick, and today we are going to be doing IXL L5 reflections. So for these problems, we're going to be given a graph, as you can see here. Okay, and then they're going to give us a shape on the graph. And this first problem, in problem number 1, we see here we have a triangle with points B, C, and D. And the instructions here say that we're going to graph the image of triangle BCD. So our first triangle is our pre-image. Our reflected triangle is going to be our image, right? So graph the image of triangle BCD after a reflection across the y-axis. So if you remember from class, whenever we're dealing with reflections, we are always reflecting a shape, like this triangle right here, over what's called a line of reflection, okay? And so right here, we see that the line of reflection is the y-axis. It wants us to reflect our triangle over the y-axis. So the y-axis is this line right here, right? You can tell by the little y up here. Okay, the y-axis is always vertical, so up and down. And the x-axis, you can see the little x right here. The x is always left to right. It's always horizontal, okay? So we're going to reflect across this line right here. And so there's a couple different ways you can do it. But the first way I'm going to show you is we are just going to count. So if you can count, you can solve these problems pretty easily. So the big rule is that all pre-image points, so all points on our first shape, our pre-image shape, each point is going to be the same distance or equidistant from the line of reflection as the resulting image point. So for instance, C is 1, 2, 3 units away from our line of reflection, right? The y-axis is our line of reflection. And that means C prime has to be 1, 2, 3 units away from the line of reflection as well in the same direction. So I'm going to click here. That's going to be C prime, okay? Now let's do B. B is 1, 2, 3, 4, 5, 6, 7 units away from the line of reflection, and B prime is also going to be 7 units. So 1, 2, 3, 4, 5, 6, 7. All right, that's going to be B prime. So we have C prime and B prime. And now we're just going to do the same thing for D. We have D right here, so we'll go 1, 2, 3, 4, 5. Okay, and then 1, 2, 3, 4, 5. And there you go. You can see here that we have successfully reflected our pre-image triangle, triangle BCD, over to our fourth quadrant right here. Okay, so we submit, and bam, fantastic, good job. So, problem number 2. We have a different shape. This time we have a rectangle, and it says that it wants us to reflect our triangle STUV, over the y-axis again, just like last problem. So we're going to go to the graph, and we're going to see that the y-axis is right here, and we're just going to reflect this rectangle over that line, so it's over here. So last time we counted, you can do that again, right? You can go 1, 2, 3, 4, and 1, 2, 3, 4. No problem. Or you can do this. You know that V, for instance, right? The point V is at negative 10. The distance between negative 10 and our line of reflection is 10, right? To get from negative 10 or negative 10 to our line, it's 10 units. It has to be because we're at 0 right here, right? So from negative 10 to 0, it's just 10. So we don't have to actually physically count. We can just use the numbers on the graph. So if V is 10 units away from the line of reflection, we know that V prime also has to be. Now 10 units after our line of reflection right here, if we start at 0, 10 plus 0 is just 10, so we know it has to be at 10 right here, okay? And so let's use that method for the other 2 points as well. S is at negative 10, so that means S prime is going to be 10 after 0, so positive 10. And then T is at negative 4, which is 4 units away from 0, right? There's 4 units between here and there. And so we're just going to go 4 away in the positive direction, and bam, that is it. Okay, submit. Okay, I'm going to jump a level here. Okay, we are now at the point where we are going to look at lines of reflection that are not on the x or the y-axis. So here we have kind of a diamond. It looks like a rhombus, right? And it tells us to graph the image of rhombus EFGH after a reflection across the line x equals -2. So what that looks like, and I'm just going to briefly go over here using my snipping tool so I can draw a line. It wants us to reflect over the line x equals -2. So when it gives you something like this, the line x equals -2, there are two components here. Number one, there's the letter, and number two, there's the number, right? So the equation x equals -2 for a line just means that we're going to go to the x-axis. So remember, the x-axis is this line right here. Okay. And we're going to go where it equals -2 on the x-axis. So if we go back and forth on our x-axis, we see right here is -2, right? -2 is right here. And so the line is going to go straight through -2 on the x-axis. So that means this entire line right here straight as possible. That is going to be our line of reflection. Again, the line x equals -2. That just means our line of reflection is going to be where -2 lies on the x-axis. That's all. Okay, so we have -2. And in this case, the line is going to be vertical, like this, up and down, right? You can always try, if you get confused between whether it needs to go up and down or left to right, you can try it both ways. Let's say we tried doing the line horizontally instead of vertically, so left to right instead of up and down. If we try that, that's just the x-axis, right? It doesn't even matter that we chose -2 here. That's just the x-axis. That doesn't make any sense. So right here, the line x equals -2 is going to be our line of reflection. And just like the other couple problems, we can count. So I'm going to go back to the problem so we can actually mark it. Okay. And our line of reflection is right here at -2, right? Right here. So we're going to go F, we'll go 1, 2, and we're going to stop because we just hit our line of reflection. And now we're just going to go 2 more in the same direction for F prime. So 1, 2, bam, F prime. Let's do the same thing for G. G will go 1, 2, 3, 4, 5, 6, stop. We're at -2, our line of reflection. Now we're going to go 6 more. 1, 2, 3, 4, 5, 6. Now we're going to go down to H, and we see H is at 4. The distance between 4 and -2 is 6, so it's 6 units between here and here, just so we don't have to count. So we're just going to go another 6 units. And so if we start at -2 and go another 6 units, we end up at -8. And then lastly, E right here is just 1, 2 away, which means we're just going to go another 2 to the left. 1, 2. And there we have it. We just reflected over our line x equals -2. Remember, our line of reflection is right here. The line x equals -2 just means -2 on the x-axis. So we click submit, and also fantastic. Very good, very good. Hey, this problem is just another one for the y-axis. So I'm going to skip a level. Ooh, this is a good one. All right. So instead of giving us the line of reflection as the y-axis or the x-axis or x equals something or y equals something, in this case, it's going to give us y equals -x. Okay, you're going to see some problems on here that are y equals x. We'll go over y equals -x first because that's just what came up. And so what that means is the line y equals -x is a line, again, let me bring this up to show you. The line y equals negative x. Well, let me do this. Let me start with y equals x. So y equals x is just a perfectly diagonal line like this. This is the line y equals x. And you can kind of think about it this way. I'll say y equals x. You could think of it this way. If we plug in 1 for y and 1 for x, our coordinate is going to be 1, 1. If we plug 2 in for y and 2 in for x, our coordinate is going to be 2, 2, 3 and 3, 4 and 4, 5 and 5, and so on and so forth, right? Same thing for -1 down here, -2, -2, -3, etc., etc. So that's how we can graph the line. We don't just kind of make it up. Okay, it goes through each of those points. So if this line right here is y equals -x, we're going to kind of flip that logic. So if we plug 1 in for x, we're going to plug in -1 for y. So I'm going to erase all this. Okay. Grab my pen here. And we're going to go -1, +1, -2, +2, right? Same type of logic, except instead of 2, 2, we're going to go -2, +2, 3, 3, -4, 4, etc. And then you can flip it around, right? Instead of -1, +1, we can go +1, -1. Down here, +2, -2, +3, -3, so on and so forth. And when we draw our line through all these points, continuing on through the edge of the graph, we have our line y equals -x. Okay. And so the principle for reflecting our shape down here is going to be pretty much the same. Our points are going to be the same distance away from the line of reflection. So r is going to be the same distance away from the line of reflection as r prime, right? Except one thing changes, which is the direction. So for instance, if we want to reflect r over this diagonal line, this line of reflection that we have, y equals -x, we're going to count the distance. So r is going to be 1, 2, 3, 4, 5, 6, 7, 8. But instead of going and continuing up 8, we're now going to change directions. We're going to go to 1, 2, 3, 4, 5, 6, 7, 8 in the x direction. So we started in the y, the up and down, right, the vertical, and then we had to switch to the horizontal, left to right, in this case, right. Okay, so we just reflected r over there, r prime. And then you can do the others the same way. S is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's going to be S prime. So we have Q as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll go up now. We start at -10. That means we have to end at +2 up here. Okay, that's Q prime. And lastly, we have P. And another thing you can do is you can kind of look at this shape and then look at what we have already and just kind of see that P is going to end up right here to complete the shape, right? Okay. And that's our answer. We're just going to draw the lines here. And so I'm just going to translate that over pretty easily. So we're going to go this and here. Okay, and then see 4 high, 4 wide. Should be that. Okay, so we submit it. Bam, and we got it.